Welcome back. This is the last video that I want to go over on the topic of chemical kinetics. The first is we looked at three different types of reactions: first order, second order, and zero order. Now, if I had charged $1 for every time I told this question will be on my exam or an exam outside of the situation, I would have been $1 million. I would have been a millionaire by now because I've said it so many times. And several people have actually taken it seriously, and they actually did well because they saw it coming. And these are the two concepts that certainly will make it to any exam. Okay, one of them is people will tell you either the reaction is first order. Now you find a graph that represents the first order, or they give you a bunch of graphs and ask you which one is first order. It's kind of the same thing. Okay, or have you draw one, which could be on an AP Chem where you have it's free response type. But for multiple choices, let's look. So if you're plotting concentration as a function of time, just concentration as a function of time, and you end up with a negative slope, okay, which is going down. This is a negative slope because it's going this way, not this way. It's going down, not going up. This is zero order. If you have natural log of concentration versus time, and you have a graph that has a negative slope, that is first order. And if you have 1 over concentration as a function of time, and you have a positive slope, that is second order. Now there is something else that is also first order, which is if you have A as a function of time, okay, and then you have an exponent decay. This is called an exponent decay. This is also first order. So these are the four graphs that you need to remember. Like I said, if I had charged $1 for every time I've said this, and every time someone had to listen, I would have been a millionaire by now, because this will be on almost any exam in one form or the other. Okay, if it's not, don't complain to me saying, yo, you said that you're going to become a millionaire and it was not there. Well, hey, I don't design the exam, but anyone that designs the exam usually throws this in because they're getting the exam out of some kind of archive, and they're not sitting there creating these exams. Okay, so people usually pick it because they look like, oh, that's a lot of graphs. People are going to get confused, because when I put all this and I change the X and Y axis, I get multitudes of combinations. Your brain would go bonkers not knowing what to do with which choice to pick. But this is all you have to know for the graphical relationship. Now, another concept that's very easy but often overlooked, are not taught right, and students get it wrong. Well, half-life is basically time taken for half of the reactant to be consumed. Half of the reactant or product or to be consumed. Reactant is usually consumed. So say I start with A, which is a species, which is at 1 molar. How many half-life it's going to take to get to, say, 0.25 molar? So half-life, one half-life is, well, the half-life symbol is T half, okay? This is half-life, okay? And I said half-life is the time taken for half of the reactant to be consumed. That is, concentration is half, or concentration is half, okay? Halved is what I meant to say. So 1 molar to half a molar would have taken 1 lifetime, right? That's 1 lifetime. And half to 1/4, which is 0.25, would be one more half-life. So we have a total of 2 half-lives. That's one. And then there's also another concept that's very important. If the reaction is, say, first order, okay, and they ask you to calculate the half-life, there's an equation which is T half equals 0.693 over K. You do not have to remember this. K is the rate constant. Usually you will be given the rate constant. All you have to do is substitute 0.693, divide by the rate constant that you're given, and you'd be able to find the half-life. Now this is the equation. You do not have to memorize. I will try to give a problem on the homework, but I don't want to solve an actual problem here, because what is there to solve? You just have to plug in the value of rate constant, which will be given to you in the question, and this equation will be in the appendix. Just put whatever value in place of K and get the T half. Okay, and that's all I have to say on the topic of chemical kinetics. I have another 1.5 topic to get through. So the more frequently you watch these videos, the better you're going to be in time to take the exam. All right, so stay tuned for a little bit of electrochem and a little bit of thermodynamics, and we will be wrapping this topic on Chem 175. Stay tuned.